When you think of the Wright brothers, you probably picture that one single iconic moment, the first flight. But that image, well, it's just the final scene of a way more interesting story. It's a story that isn't really about that one moment of success. It's about a brilliant process of failure and testing and just pure perseverance. Okay, let's get into it. Everything starts with this number, 12. Just 12 seconds. That's how long the first controlled, powered flight in all of human history actually lasted. It's almost crazy to think about how short that is. And yet, in those 12 seconds, Wilbur and Orville Wright basically changed everything. They proved that flying wasn't just some fantasy. But the real magic isn't in that number 12. No, the real story is the journey. All those years of frustrating, careful, brilliant work that made those 12 seconds even possible. It's a story about inventing a process just as much as it was about inventing a machine. And that journey starts right here, in what looks like the middle of nowhere, Kitty Hawk, North Carolina. See, the Wrights knew they couldn't just build a plane and hope it worked. They needed a lab, a testing ground. Really, they needed a place where they could fail, over and over and over again, safely. So why here? Why this random spot? Well, it was like the perfect storm of ideal conditions. They needed those strong, steady winds to give their gliders some extra lift. They definitely needed soft sand for all the crash landings they knew were coming. And they needed to be left alone, to work without distractions. They actually wrote to the U.S. Weather Bureau, and Kitty Hawk just ticked every single box. And then there was this, the final piece of the puzzle. A local guy, William Tate, wrote them back. And he didn't just confirm the windy conditions. He offered his full enthusiastic support. That pretty much sealed the deal. The Outer Banks would become their own private laboratory. And there's a huge lesson there, right? Sometimes finding the right environment to work in is just as important as the work itself. Okay, so let's get to their first attempts. Before they even dreamed of putting an engine on anything, the Wrights had to solve the real problem of flight, control. They started with gliders, and those early experiments between 1900 and 1901 were a total roller coaster of hope and, well, mostly disappointment. So you can see from this little report card, their first glider wasn't a total failure. I mean, the lift was really weak, way less than their math said it should be, and that's a huge problem. But their crazy new idea for a control system, this wing warping thing, it actually worked like a charm. So they had one critical piece of the puzzle, but the overall design was just wrong. So for their 1901 glider, they did the logical thing. They just made it bigger to get more lift. Seemed obvious, right? Well, it was a total disaster. It performed even worse. The lift was still awful, only a third of what it should have been, and now the bigger wings made the whole thing dangerously twitchy and unpredictable. This was a massive step backward, a real rock-bottom moment that almost made them give up completely. But that failure, that moment of near despair, is what forced them to a crucial realization. They started thinking, maybe the problem isn't our design. Maybe the problem is the science that everyone is using. And this, right here, is the moment the Wrights went from being just really smart mechanics to becoming true pioneering aeronautical scientists. This was the question that just ate at them on the long train ride home to Dayton, Ohio. They had followed all the accepted formulas. They used the data from the great aviation pioneers of their time. So why on earth wasn't it working? The answer was as simple as it was totally shocking. The basic data they were trusting, the numbers published by famous guys like Otto Lilienthal, it was just plain wrong. And that led them to this incredible conclusion. When the textbook is wrong, you have to write your own. And that's exactly what they did. They went home and built this simple but brilliant little wind tunnel right there in their bicycle shop. And this slide, this shows their most important discovery. See, Smeaton's coefficient, it's a key number for calculating air pressure, which is absolutely essential for figuring out lift. The value everyone had been using since the 1700s was 0.05. The Wrights discovered it was actually 0.0033. Now that might not sound like a big deal, but it's off by more than 30%. That was the ghost in their machine. So now, armed with their own correct data, they went back to the drawing board with a ton of confidence, and the result was their 1902 glider. And this wasn't just another small improvement. For all intents and purposes, this was the first real airplane. It just didn't have an engine. Yet. Every single part of this new machine was a direct result of their wind tunnel research. They designed these longer and narrower wings because their tests proved they were way more efficient. They changed the shape of the wing's curve, the airfoil. And crucially, they added a movable vertical rudder at the back to fix all those control problems from the 1901 glider. To really get how revolutionary this was, you have to understand three-axis control. See, to really fly, you have to control the plane's pitch. That's the nose going up and down. You have to control its roll, the wings banking left and right. And you have to control its yaw, the nose turning left and right. Nobody before the Wrights had figured out how to solve all three of those things at the same time. And this is how they did it. This was their single greatest breakthrough. They linked the wing warping for roll with that new rudder for yaw. By connecting those two movements into one system, a pilot could finally make these smooth, controlled turns in the air. They had literally cracked the code of flight control. And did it work? Oh yeah, it worked. 1,000 times over. In the fall of 1902, they made somewhere between 700 and 1,000 successful glides. They weren't just testing anymore. They were flying. They were mastering their machine. Some of those glides lasted for over 20 seconds. The problem of flight was solved. So now, with the mystery of control finally solved, there was really only one major hurdle left. They had to turn their perfect glider into a powered airplane. This wasn't a scientific mystery anymore. It was just a set of really tough, really complex engineering problems. And they just tackled each one with that same methodical genius. First, the engine. Car engines back then were way too heavy. They needed a power-to-weight ratio that just didn't exist. So, with their amazing shop mechanic Charlie Taylor, they just built their own, even casting the engine block out of lightweight aluminum. Next up, propellers. Most people thought a propeller was basically a boat screw for the air. The Wrights realized, no, a propeller is just a wing that rotates. Using their own wind tunnel data, they invented modern propeller theory and carved the first efficient airplane props by hand. Problem, solution, done. But even in those final days, man, it was not easy. A propeller shaft broke, sending Orville on an emergency trip all the way back to Dayton. Then, on December 14th, Wilbur won the coin toss for the first try, and promptly stalled it and crashed. They spent 3 days making repairs in the freezing cold with the wind just howling, but they just would not give up. And then came December 17th. It's Orville's turn, and he flies for 12 seconds. And just like that, history is made. But they don't stop there. They fly 3 more times that morning. And look at the progression on that last flight. Wilbur stays in the air for almost a full minute, covering 852 feet. This wasn't some lucky hop. This was definitive proof. They had done it. They had achieved sustained, controlled, powered flight. They had invented the airplane. So the real takeaway here isn't about those 12 seconds. The 12-second flight wasn't the invention. It was more like the final exam. The real invention was the process, questioning your assumptions, building your own data when the old stuff is wrong, and just obsessively testing every single piece of the puzzle until it's perfect. It really makes you wonder, doesn't it? What huge problem we face today could be solved not with one giant leap, but by patiently and brilliantly figuring out how to fail, learn, and try again.